Third and final type of dispersion is called waveguide dispersion. This one is it's more like an extrinsic factor. It depends on the waveguide design. So this is like similar to your extrinsic attenuation. If your waveguide, as in your optical cable, is what's the diameter of the optical cable? Is it bent or is it straight? This depends on such factors. This one is generally negative because we generally try to engineer a cable which does not allow for such dispersion to happen. So it is almost negligible, but it exists, and it depends on the shape and size of your fiber optic cable. So your total dispersion will be intermodal plus chromatic plus waveguide, and they will always be of the order intermodal maximum followed by chromatic followed by waveguide. So those are the three types of dispersion, how they work and the basics of it. Moving on, so we saw that attenuation and dispersion are problems which lead to loss of signal, and that is obviously something we want to avoid. Now attenuation as such is a problem which you cannot do much about. Intrinsic attenuation, it is a property of the material itself, so you cannot tell the material don't do this because that is its inherent property. The only thing you can do is you choose an appropriate wavelength such that the attenuation is minimized, and for that we saw the first window, second window, third window. And extrinsic attenuation, it depends upon the distance, the terrain over which you are going to lay an optical fiber. So if your task necessitates your laying a fiber from Chennai to say Rajasthan, then you have to lay it irrespective of the length, irrespective of how many bends are there, you have to lay the fiber. So you cannot say it is a bent road, so I will lose signal, I am not going to lay a fiber. So attenuation is not something you can really try to solve. Dispersion on the other hand is more like it is a sort of scientific mathematical phenomenon. So we can try to counter it using some techniques. So what are those techniques is what we are going to look at now. There are two main techniques: reduce the time delay between the different modes, or reduce the number of supported modes to 1. It makes sense, right? So the whole problem in dispersion is when you have different modes or phases, there is a time discrepancy between them. So you try to reduce or minimize that time discrepancy, or if you don't want that trouble, if you find it too difficult, you make sure that your cable supports only one mode, then there will be no discrepancy. So these are the two ways. So now we'll be looking at each of these in detail and seeing how each of these is accomplished.